In continuation of the chapter Electrochemistry, we have the topics electrolysis and electrolytic cell. Electrolytic cell. Now, the term electrolysis is defined as the process of decomposition of electrolyte into ions and their subsequent deposition at respective electrodes by passing electricity is called electrolysis, and electrolytic cell is the device which converts electrical energy into chemical energy that I have also discussed earlier in this chapter. Now, how electrolysis is carried out in electrolytic cell? For this we take one example, electrolysis of molten NaCl using suitable electrodes. For this, we draw a simple figure. This is a vessel containing molten NaCl and two electrodes, one anode and one cathode. Here is anode, here is cathode, is joined with a battery or cell. Now, with the passage of electricity, molten NaCl breaks down into sodium cation and chloride anion, and at the same time they begin to deposit at their respective electrodes, and this is shown by this reaction. NaCl molten by electrolysis. Here is electrolysis, Na plus and Cl minus in the form of ions we are getting. Now Na plus moves towards cathode by taking one electron at cathode, and at the same time Cl minus changes into Cl by losing one electron, and this is at anode. Here also at cathode reduction takes place and at anode oxidation takes place. Now we can have another example. Here example number 2 is electrolysis of aqueous solution of NaCl using suitable electrodes. Now here the solution contains two different cations and two different anions. Two cations are Na plus and H plus, and two anions are Cl minus and OH minus. Now, with the help of discharge potential, which cation or which anion will be preferentially collected at cathode and anode, this is based on the fact that lower the discharge potential, greater will be the tendency of an ion to be deposited at respective electrode. So the term is discharge potential. Lower the value of discharge potential, greater will be the tendency of ion deposited at electrode. Now here we can compare the discharge potential of Na plus with H plus and Cl minus with OH minus. This discharge potential can also be expressed in the form of a standard reduction electrode potential and a standard oxidation electrode potential. Whether a standard electrode potential can be taken or discharge potential can be taken for the ions to be deposited at respective electrodes. So here H plus, because of its lower discharge potential, is collected at cathode and H combines with another H atom to form a stable hydrogen molecule at cathode. Similarly, here Cl minus has lower discharge potential and it can be collected at anode by losing one electron, and this Cl again combines with another Cl to form a stable chlorine molecule at anode. So in this way we can have the electrolysis of various electrolytes using suitable electrodes. Now we move on to the term Faraday's law of electrolysis. Faraday's laws of electrolysis. So let me write Faraday's electrolysis, amounts of a substance of an electrolyte deposited at respective electrode is directly proportional to the quantity of electricity passed through the electrolyte. Now, this statement can be formulated as W is equal to Z I T. In fact, this relation comes as W is directly proportional to Q and W is equal to Z into Q, but Q is equal to IT. So we can have W is equal to Z I T, where W is equal to mass of the substance deposited, I is equal to electric current in ampere, and here is a small t. T is equal to time taken for deposition. So this is Faraday's first law of electrolysis, and lastly Z is equal to electrochemical equivalent of the substance. Which is a proportionality constant. Now this Z can also be calculated by the formula Z equal to E by F, where E is equivalent mass of the substance and F is Faraday constant. Further, E is equal to atomic mass A by valency V into F. We can find out Z if it is not given in the question. Now, second law. According to second law of electrolysis, when the same quantity of electrolyte is passed through different electrolytes, when same quantity of electric current is passed through different electrolytes using different electrodes, the amounts of the substance deposited at respective electrodes are directly proportional to their equivalent masses, and this is in the mathematical form written as W1 by W2 is equal to E1 by E2, where W1 and W2 are the amounts of different mass of the substance deposited, and E1 and E2 are their equivalent masses respectively. Now, we have some questions related to electrolysis. But before that, two important points that is to be noted down. Point number one is 1 Faraday of electricity or electric charge required or involving 1 mole of electron. Second point is 1 Faraday of electricity required for deposition of 1 gram equivalent or sometimes 1 mole of the substance deposited at electrode. So these 2 points are very important when doing some numericals based on Faraday's law of electrolysis. Thereafter, some of the questions, important questions, they are also available in NCERT. Write the electrolytic reaction. Write electrolytic reactions for A. Aqueous solution of CuSO4 using Cu electrodes and B. Electrolysis of aqueous solution of CuSO4 using inert electrodes. C. Electrolysis of molten calcium bromide CaBr2 using suitable electrodes. So these are the important questions. You can do it nicely. Thank you.